Good morning, ladies and gentlemen. My name is Yan Yan from Civic Exchange. Thank you very much for coming to this public forum, Climate Change and the Asian Monsoon, Impact and Consequences for Asian Civilization, co-organized by Civic Exchange and the Institute for the Environment and Gene Sustainability of the Chinese University of Hong Kong. It's actually a public event, a free one, of a week-long international conference, the AGU Chapman Conference on the Asian Monsoon, organized by the Chinese University at the Chinese University in Shatin this past week. And we are very happy to be able to collaborate with the Institute to organize this side event to bring the messages from Shatin to Central on Asian Monsoon. As you may all know, actually, for Asian monsoon, according to the IPCC report, the latest one, monsoonal rainfall is going to increase in the future and affect a larger area. But how are we going to deal with this? What's going to happen in the future? And we're very delighted to have some of the experts and scholars in the field on the subject to come to here in Central to share with us their insights and their knowledge. This morning we're going to have two sessions. In the first sessions, we're going to look at what happened in the past and what may happen in the future. And after the break, in the second session, we're going to have a look at what can we do? What are some of the actions that we can take to address the issues? So perhaps now, before I invite the moderator for this first session, I'd like to say some thank you to some very important people and partners. Of course, the first one is the Institute. Thank you again, Professor Lau. The second one is the PwC for providing the venue. And then thirdly, the sponsor Swire Trust, providing financial resources to make this event happen. Also, French Consulate General, some representative here, thank you for sponsoring part of the event and also bringing the guests to Hong Kong, and also Culture Foundation. So without further ado, let me introduce Professor Lau, Director of the Institute of Energy, Sustainability and Environment, to come and moderate the first session. Professor Lau, please.
Thank you, Yan Yan. So the first session would consist of three presentations by major speakers at the Monsoon Conference in Shatin, and they will be given 20 minutes each to make their presentation. And then after they tell their stories, there will be a question and answer period at the very end. Okay? So I would like to now introduce the first speaker, Professor Peter Clift, who is the Charles T. McCord Professor of Petroleum Geology at the Louisiana State University. He is the chief convener of the conference at the Chinese University, and he will speak on paleoclimate. Can geologists tell us about the variability of the monsoon over the last 20,000 years? Peter?
Thank you so much. And it's a great pleasure to be here and to talk to you about the geological history of the monsoon. So even a petroleum geologist can care about climate change, and mostly because it's a fact. And I'm going to show you a little bit of information about why, how we know this. I'm sorry, I'm going to walk around. I get nervous behind these desks. So what I'd like to do is to show you, of course, well, briefly, what the monsoon is, right? So what the monsoon is, this giant climatic phenomena that is common to many of the continents of Earth, but is particularly strong in Asia. And what you're looking at here is a little map showing in colors the rainfall, the intense colors, particularly, say, over the Bay of Bengal, in Southeast Asia, strong rainfall, and the arrows are showing you here wind strength. So you can see that the monsoon, the summer monsoon, is something relatively diverse across the continent, that we have strong winds and more dry conditions in the west and heavy rains in the center, and then a sort of a mixture between the two over much of China. So measuring the monsoon is not always very easy because it's a changeable beast. It depends where you are if you live in Karachi, it means something different than if you live in Dakar or in Hong Kong. And so one thing to remember is that the monsoon is particularly strong in Asia, partly because Asia is such a very large continent, and partly because of the Tibetan Plateau, which is a unique mountain. It's the biggest mountain on Earth, actually, for the last 600 million years, which is a big number, but a big number that impresses geologists, which is why somebody like me is interested in the first place. And so people have suggested that one of the reasons that the monsoon is so strong is because the sun heats the air over the Tibetan Plateau in the summer, and that this intensifies the low pressure system that sucks in moist air off the continents that then rains up against the edge of the plateau during the summertime. So that's why it's there at all, and why it's been here for maybe tens of millions of years. But of course, we don't really care about that as human beings, right? We're caring more on short time scales. And we do know that the monsoon has changed in the recent past, that this is, for example, a record from India. This is all India rainfall here, and you can see a cyclicity here. So we know it changes on shorter time scales too, and we know that that's linked to other climatic phenomena, like things like the El Nino phenomena in the Pacific Ocean, that at least historically, before the 1980s, El Nino times were times of weak rainfall in India. Well, that's all very well. We know, that's when people we have instrumental data and records, but the geologists, what we can do is help to feed that back into the past, to reconstruct over longer time scales, to use the geological record to tell us how the monsoon evolved before we have any written data that human beings have collected. And so there are a number of ways that we can look at this. And one of the most popular is looking at cave deposits. And the cave deposits, well, stalagmites, right? This sort of thing, with the beautiful laminated sequences here, each one representing a year's worth of precipitation of the water dripping through the caves. And why this is useful is because these preserve the composition of the water at the time that the stalagmite forms. In particular, we can measure things like oxygen isotopes. And you can imagine, since the heavy isotopes fall out of the rain clouds more easily than the light ones, and so when you have a light rain, you have rainfall with a relatively heavy composition, and when you get strong rainfall, you get light composition. And so what we can do is go back, and we can use this as a tape recorder to look at how strong the rainfall has been in the past. And since we can date the stalagmite, it allows us to look in extreme detail. This is the one from a place called Donga in southwest China, not so far from here. And you can see this terrifically complicated record that has been reconstructed looking at how the monsoon has changed, in this case, since about 9,000 years ago. And that every one of these little blips is terribly meaningful is another question. But what we can see is, first of all, a rather long-term decline from about 8 or 9,000 years ago. And we also see some important events, things that are a weakening phase here at 8.2, and you can see another that have been highlighted here in these little yellow bands. And these are interpreted to reflect intense droughts that went on for maybe decades or even hundreds of years. And we do know that, therefore, by comparing this very detailed cave records, this is another one from near Shanghai, this one in Southwest Asia, and what we see is that we see a strengthening of the monsoon that happens after about 10 or 11,000 years, and a maximum around 8, and then this decline that we see across Asia. And we can compare that with things like ice core records, and what you can see here is that they don't compare at all. So once the Holocene, the modern warm period, has begun, that's pretty stable. But these decline. So we know that although generally speaking, when the world is warmer, we get a stronger monsoon, that there's more to it than that. And in fact, we also believe that solar forcing, the strength of the sun's energy beating on the planet is important, that we've seen a decline of that over the last 10,000 years, and that this is probably one of the principal things that guides the long-term development of the monsoon. There's more to life, however, than stalagmites, so there are other records also in China to a large extent, in the Lus Plateau. This is near Xi'an here. You can see this big road cut section where we have these laminated sediments. And effectively what we're looking at here are little red things which are soils formed during wet times, and white things which are formed during drier times. These represent the dust that's been carried on the winds out from the west and has accumulated in the Loess Plateau. People have been able to use that and a series of proxies of physical properties to look in detail, and you can see here we have quite a long-term record stretching over about 60,000 years, where we can look at how the monsoon has changed in China over that time period. And when these agree with our cave records, we begin to get a good feeling about how the monsoon has changed. Then there are things which really relate, for somebody not like me who really likes rainfall, that the monsoon for me is rainfall. There are very good proxies in terms of lake records. It seems rather intuitive, you know, where the lake is full of water, there's probably been quite a lot of strong monsoon. When it dries up, the monsoon is weaker. And so in places like India, this is a dry lake bed in Rajasthan, and if you core into it, you get these, again, very laminated, beautiful, high-resolution records with each little layer representing an annual flooding event or drying event. And again, we see here, similar to the cave record, here a drying up when we core deep into the lake here. This is about 20 meters here. And what we can see here is a drying up with the thing finishing around between 4,000 and 5,000 years ago. And that turns out to be a common feature that we see where there's been a strong weakening of the monsoon, again, around 4,000 years ago, about 2000 BC. And lake records have also been collected in China, this one actually from the Leizhou Peninsula in southwest China, where we looked at titanium contents. The idea here being strong rainfall washes sediment, including titanium, into the lake, and that we see pulses of that when the monsoon is strong. And so you can see there's quite a lot of variability here, that we have stronger dry and wet phases. This particular study, they tried to relate that also to phases of change in Chinese dynasties through time. But you can see here we get a relatively high resolution record. This is 4,000 years of time on the bottom here. And you can see how some of these changes have been really quite precipitous. So, you know, you've had strong phases followed by very then strong, powerful, long-term drying, that the climate changes quickly, stays like that. We also get records in places like in India, again back in Rajasthan, and actually in the western Himalayas. Here you can see an old lake level here. You see that thing in the picture there, that's the edge of a former lake. And we can also use the lake levels themselves to tell us how strong the monsoon has been in the past. And in this case, you can see they're not all the same, and there are good reasons for that, because it's slightly complicated. But again, you can see this commonality where we have high lake levels at about 6,000, 7,000 years ago, and that they weaken after about 5,000. Likewise, there are more things you can do with lakes. That they act as like natural tape recorders, that things like pollen are blown into the lake, and that those can be used to look at what the type of vegetation that grows around the lake. So again, you can imagine that of course we get a different type of flora flourishes when it's wet conditions compared to when it's dry. Let me skip on. So again, there's a whole bunch of stuff these guys have been measuring here. This is in Ladakh in western India, up here on the western edge of the plateau. And again, they highlight this sort of 8,000 year time as being one of maximum intensity, but a weakening. And what was interesting when they looked at pollen, this is a pretty picture of some pollen here, and what we saw here is that there was, again, a strong decline in monsoon strength after about 4,000 years ago. There's more to life than lakes. We were hearing at the conference also about tree rings. So you can imagine that trees sort of like to grow when it's nice and wet, and when you have an arid year, that we get a drying and a very narrow band. And so this is an example of some of the records that they've generated, mostly stretching over about 2,000 years, where the identification of narrow bands has been related to what you see here. They correlated to dry phases. This is years 1250 to 1500, and in this is an example from Southeast Asia, where they used tree records and correlated them with the speleothem, with the stalagmite records, to identify periods of drought, which in this case they linked to the collapse of the Khmer Empire, the Angkor Wat civilization. And then there are things that people like me do, that we look at sediment and in deltas. And you can imagine that the soil that you get in a dry climate is rather different from one you get in a wet climate. And that sediment is then washed into the rivers and accumulates in deltas where we can go out and look at it. And we've done that actually in the Pearl River. But I'm going to show you quickly here, not only in the Pearl, but in the Mekong, that we look at a variety of different chemicals and different minerals that can be measured. And you can see this one in the middle in particular is interesting. It was done by a colleague from Paris who showed an increase here in chemical weathering, again at the start of the Holocene, to showing that peak in activity about 8,000 years ago. So this gives us a good feeling, right? When you have many different indicators, independent indicators that show the same sort of trends, that gives us confidence that the whole thing is not just one enormous illusion, that we're getting a similar result from different types of data. Speaking of rivers, at the meeting we were also learning how, you see, that's 2,000 years, oh sorry, that's the last 1,000 years of record. So what we're looking at here is in rivers flooding events. So people also been now looking at sediments in river valleys, looking at intense rainfall events. So not necessarily the total precipitation, but looking for extreme climate events. And what you're looking at here is between the year 1000 and the present day, and these blue bars are showing you where there's been an absence of flooding. So what we see here is that there's this gap between about 1300 and about 1800 where there was very little flooding. These are Indian river systems. And that this correlates with a period known as the Little Ice Age, when the world was colder and the monsoon drier than usual. And then this is a zoom up here of the last, since about 1840 to the year 2000. Again, Indian river systems here. These are flooding events, and you can see the geological record is now showing us an intensification of those flooding events since about 1920. That this appears to have been something, extreme rainfall events becoming more problematic in the 20th century. Okay, and then the last thing I wanted to show you also were river sediments from India. This is the type of study, relatively new development using organic chemical indicators. And what we see here was that this is 5,000 years worth of history here, and you can see these are leaf waxes, plant waxes that they measure in sediment in river deltas. And they're showing a drying here since 5,000. That's consistent with what I already showed you. But you'll also notice that there are these steps. There's the step first at 4,000 BC. And then there's another one here at about 1,800 years ago. And that this correlates, so we have a long-term drying. But on top of that, this record also shows us about extreme events. So here what they're looking at are a type of fossil which is correlated with salinity. And what you notice here is that after 3,000, we get more and more and more of these. So this shows us that in the Bay of Bengal, in this particular case, the Godavari Delta, we are having extreme drought events becoming more and more common after 3,000, and particularly after 1,500 years ago. And that this correlates, in fact, with the establishment of this, with a cultural transition, the start of tank irrigation that we see in archaeological sites across India. So not only do we have the geological record tells us about the long-term trend, but it also tells us about intense events, major flooding events or major drought events, and we see a consistent pattern here between different types of data. So just to round up here now, what I hope I showed you is that we have a different set ways of looking at the monsoon intensity using the geological record, and that we can look at marine records or cave records, pollen records, and that they show a consistent pattern where we have strong monsoon in the early part of the Holocene about 8,000 years ago, and then a drying after that time. sometimes so dry about 2,000 years ago we don't even get any deposits whatsoever, and that those changes haven't always been gradual. There has been this long-term decrease, but on occasions like 4,000 years ago and 8,000 years ago, 8.2 thousand years ago, we saw sudden drying events that go on for decades at a time. So I'm going to round up here, and if you, I don't know if we do questions now or later, but anyway, I'm just going to stop anyway. So what we see is several types of geological records show similar trends of monsoon development, and that we see strong rains at about 1,000 years ago. After an increase as the Holocene established itself, saw a strong rise after 11,000, and that subsequently we've seen this long-term decrease, and that there have been sharp changes that we can identify in different types of records that give us confidence that this is a robust record. And that also there are, however, although that's a general trend, that there are important latitudinal differences. So places like in northern India, as opposed to central India, are different, and North China being different from South China. Okay, and that although times of warmer climate are often associated with stronger rainfall, and potentially in the future, in a global warming context, this is something you might wish to consider, but of course the patterns of change are uneven. So not enough just to look at one cave or one lake and say, well, that's good for all of Asia. We don't know that. This is something we're still learning. Thank you very much.